In this lecture, we are going to discuss the definition and some examples of Laplace transform. We know the differentiation and integrations are transforms, which transforms one function to another functions. Like that, Laplace transform is also another transform, which transforms from functions from domain to another domain. Okay, so we can start with the definition of Laplace transform. Let f of t be a function defined for all t greater than or equal to 0, then the Laplace transform of f of t is denoted by L of f of t or f of s, and is defined by L of f of t is equal to integral 0 to infinity e to the power minus st into f of t dt, provided this integral converges. Provided the integral converges. Okay, so this is the definition of Laplace transform. So let f of t be a function defined for all t greater than or equal to 0. Then the Laplace transform of this function is this integral, provided this integral converges. The Laplace transform of f of t is denoted by L of f of t or f of s. This notation is because when we integrating this e power minus st into f of t with respect to t and replacing the values 0 and infinity for t, the resulting function will be a function of the parameter s. So that's why we choose this notation also, f of s. Okay. Now, as an example, we can do a question. Evaluate L of 1. Okay. So here the function f of t is 1, or f of t is 1. So by definition, we have L of 1 is equal to integral 0 to infinity e to the power minus st into 1 dt, that is equal to integral 0 to infinity e power minus st dt, right? So this is equal to, this is an improper integral, so this is equal to some limit b tends to infinity integral 0 to b e to the power minus st dt. Okay, so this is equal to limit b tends to infinity, integrating this with respect to t, we get e power minus st divided by minus s from uh, t equal to 0 to b. Okay, so this is nothing but limit b tends to infinity uh, e to the power minus sb minus e to the power 0 divided by minus s. Clear? So this is equal to limit b tends to infinity e to the power minus sb minus 1 divided by minus s. Okay. Now, as b tends to infinity, here s is the parameter. If s is greater than 0, if s is greater than 0, then s into b tends to infinity. So e to the power minus sb tends to e power minus infinity. So e power minus infinity is actually tends to 0. So this is equal to 0 minus 1 divided by minus s, which is equal to s, where or when s is greater than 0. Okay, so L of 1 is equal to 1 by s when s is greater than 0. That is, when s is greater than 0, we have this is minus sb is actually uh, is negative. So we have as b tends to infinity, this is e power minus infinity, which is 0. So 0 minus 1 divided by minus s, that is 1 by s. Okay, and if s is less than 0, if s is less than 0, then we have this e power minus sb is nothing but e power a positive number. Minus sb will be if s is negative less than 0, then minus sb is a positive number. So as b tends to infinity, this will be e power infinity, which is infinity. So the integral, this limit diverges, so the integral diverges. Okay, the integral diverges. So the integral converges only if s is greater than 0. So in that case, we have L of 1 is equal to 1 by s. So we have the function 1 has the Laplace transform 1 by s. L of 1 is equal to 1 by s. So here we used this limit to find the integral of this the improper integral. So for convenience, we can use we can do like this. L of 1 is equal to integral 0 to infinity e to the power minus st into 1 dt, which is equal to, we can directly integrate or keeping the limit as 0 and infinity for convenience. So we can write e power minus st divided by minus s from t from 0 to infinity. Okay, so as t tends to infinity, when s is greater than 0, we have this is negative, this is a negative quantity, and as t tends to infinity, this is e power minus infinity, it will be 0 minus e power 0, that is 1 divided by s, divided by minus s, that is equal to 1 by s when s is greater than 0. Here we used that limit t tends to infinity e power minus st is equal to 0 for s greater than 0. Okay, so we have L of 1 is equal to 1 by s. Next question, evaluate L of t. So the Laplace, we have to find the Laplace transform of t. So by definition, we have L of t is equal to integral 0 to infinity e to the power minus st into t dt. So this is equal to uh, first function t into integral of second function is e power minus st divided by minus s into, sorry, minus derivative of t, that is 1, into integral of second function, that is this function, that is e power minus st divided by minus s into minus s, that is s square. Okay, then plus derivative of 1 is 0, etc. So this is equal to in 0 to from 0 to infinity. So here we have uh, in this case, in the second term, we have e power minus infinity minus e power 0. E power minus infinity is 0. So here we have to here first function, here we have t here. So as t tends to infinity, we have infinity into e power minus infinity. So limit t tends to infinity, t into e power minus st is nothing but, as t tends to infinity, this is infinity into e power minus infinity. So this is infinity into 0 form. So this can be written as limit t tends to infinity e t divided by e power st. Okay, so this is now infinity by infinity form. So by L'Hospital's rule, we have limit t tends to infinity, differentiating separately with respect to t, the numerator and denominator. So here we have derivative of t is 1 and derivative of e power minus st is s into e power st. Sorry, this is minus st. Sorry, yes, plus st. So e power st. So now this is as t tends to infinity, this is 1 by s into e power infinity, that is 1 by infinity, that is 0. So the limit of this is 0. So here is 0 minus, so here is 0 by minus s, right? So uh, then minus the limit of e power minus st is nothing but infinity. This is, we already know that limit t tends to infinity e power minus st is equal to e power minus infinity. So this is we know this is 0. So 0 minus e power 0 is 1 divided by s square. Okay, because this is 0. So this is equal to 1 by s square. So we have the Laplace transform of t is nothing but 1 by s square. Okay, so Laplace transform of 1 is 1 by s. Laplace transform of t is 1 by s square. Here also we suppose that s is greater than 0. Okay, to obtain these two limits. Okay, next question, evaluate L of e power minus 3t, Laplace transform of exponential function. So to find this, we have by definition L of e power minus 3t is equal to integral 0 to infinity e power minus st into e power minus 3t dt, where f of t is e power minus 3t here. So this is equal to integral 0 to infinity e power negative of s plus 3 into t dt. Clear? So on integration we get e power minus s plus 3t divided by minus of s plus 3 for 0 to infinity. T varies from 0 to infinity. This integral converges only if limit t tends to infinity e to the power minus s plus 3 t is equal to 0. So that for that we need to choose s plus 3 is greater than 0. That is s is greater than minus 3. So if s is greater than minus 3, we have this is nothing but as applying this limit e power minus infinity will be here. That means s is greater than minus 3 implies s plus 3 is greater than 0. In that case, this minus s plus 3 into t is negative. So e power minus infinity will be there when we apply this limit. So e power minus infinity, which is 0, minus e power 0, which is 1, divided by minus s plus 3. That is equal to 1 by s plus 3. Okay, that is the Laplace transform of e power minus 3t is equal to 1 by s plus 3. Okay, in a similar way, we can find the Laplace transform of some e power 6t. Okay, so this is equal to integral 0 to infinity by the definition e to the power minus st into e to the power 6t, that is f of t dt. This is equal to integral 0 to infinity e to the power 6 minus s, or negative of s minus 6 t dt. Right. So on integration we get e power minus of s minus 6 t divided by minus of s minus 6 from 0 to infinity. So here also we have e power minus infinity, which is 0, minus e power 0, which is 1, divided by minus of s minus 6. This is valid only when s minus 6 is positive. That is when uh, s is greater than 6. Okay. So this is equal to 1 by uh, s minus 6, right? So e to the power the Laplace transform of e power 6t is equal to 1 by s minus 6, and Laplace transform of e power minus 3t is equal to 1 by s plus 3. Okay, so in general we can write uh, L of e power at is equal to 1 by s minus a. Okay, generally we can write this. Now we can try to evaluate the Laplace transform of sine 2t. Okay, Laplace transform of sine 2t. By definition, we have this is equal to integral 0 to infinity e to the power minus st sine 2t dt. Here f of t is sine 2t, so e power minus infinity f of t dt is this. We can use the integration by parts here by choosing the first variable as sine u 2t and second variable as e power minus st. So we know integral uv is equal to integral u into integral v minus integral of u dash into integral v, right? So applying this we get here u is sine 2t, so sine 2t into integral of e power minus st, which is my e power minus st divided by minus s from 0 to infinity minus integral from 0 to infinity u dash. U dash is this derivative of sine 2t, it is 2 cos 2t into integral of this, that is e power minus st divided by minus s dt. Okay, so this is the integral. So when we apply infinity here, e power minus infinity is 0, so and when we apply 0, we have sine 0 is also 0, so 0 minus 0 divided by minus s. Okay, and then minus, so this term is 0, so integral 0 to infinity, here we have integral 0 to infinity, taking this outside, that is 2 by s plus 2 by s, negative into negative is plus, so 2 by s into e power minus st, or yeah, cos 2t into e power minus st dt. Okay, so uh, now we have to integrate this, so this is equal to 2 by s into integral of cos 2t into e power minus st, so we can take this as u and this as v, so we get u, that is cos 2t into integral of e power minus st is e power minus st divided by minus s from 0 to infinity, t from 0 to infinity, minus integral from 0 to infinity derivative of cos 2t, which is minus 2 sine 2t into integral this, that is e power minus st divided by minus s dt. Okay, so here this is equal to uh, 2 by s into, applying this limit as t tends to infinity, here we have e power minus infinity, that is 0, so first term is 0 minus as t tends to 0, we have cos 0 is 1 and e power minus 0 is also 1, so 1 divided by minus s, right, minus here we have integral 0 to infinity, 0 to infinity, 2 into, right, 2 into sine 2t into e power minus st dt, yeah, 2 by s into this, right. So this is nothing but we have our ln of sine 2t is e power minus st into sine 2t dt, so we have this is nothing but this integral is L of Laplace transform of sine 2t, so this is equal to 2 by s uh, into, there is 1 by s minus 2 by s into, this is a Laplace transform of sine 2t, which is equal to 2 by s square minus 4 by s square into Laplace transform of sine 2t, that is L of sine 2t is equal to this. So we can take L of sine 2t outside, so L of sine 2t into 1 plus 4 by s square is equal to 2 by s square, that is we have uh, L of sine 2t into s square plus 4 divided by s square is equal to 2 by s square. So we have the Laplace transform of sine 2t is equal to 2 by s square plus 4. Okay, L of sine 2t is equal to 2 by s square plus 4. So we can you can just verify the Laplace transform of sine 3t is equal to 2 by, sorry, yeah, 3 by s square plus 9. Okay, and generally we have L of sine 80 is equal to a by s square plus a square. We can just try to prove this in say similar way of doing this problem. Okay. Okay, so we can try any other problems like that, and you will also get the Laplace transform of cos 80 is equal to s by s square plus a square. Okay, Laplace transform of cos 80 is equal to s by s square plus a square, and Laplace transform of sin 80 is equal to a by s square plus a square, etc. Here also we use that the S is greater than 0. Okay, that is this result holds only if S is greater than 0, right?